This is part 9 in a series of videos in which I'm attempting to repair this Wren executive computer system. In the previous video I got as far as identifying a possible fault on the peripheral data bus. When we looked at the data going onto the bus, it appeared that bit 7 was stuck high. So when the Z80 was trying to put data onto the peripheral data bus, it does that through a 74LS245 bidirectional buffer chip. But when it was putting data out onto that data bus, bit 7 always appeared to be high. And it was odd because when we looked at the line with the scope, the line was switching, so it does appear this may be one of those marginal cases. But I couldn't be sure it was the buffer. It's soldered to the board and I didn't want to take it out and just start randomly swapping components. So I looked around the board trying to find any other components that were connected to the same bus. So I've removed all the components I could find and that I could remove, and the machine would still go into its self-test. As we mentioned in the previous video, I couldn't remove the floppy drive controller because that prevents the Z80 running at all. But I did find several other chips that were on the same bus and I removed those. But it made no difference, the self-test still failed, and if you recall, the self-test failed on the loopback test for the UART, so we were getting 6 flashes of the power light to indicate the fault. I couldn't find anything else wrong. I checked all the tracks and there were no shorts or open circuits, and none of the components seemed to be dragging that line down. So eventually I swapped out the buffer chip. As I say, it's 74LS245. They aren't too bad in terms of reliability, but this particular one has a very hard life because it transfers data to all the peripheral ICs, and there's quite a few of them. So we'll give this a quick test. So press the test button and sure enough it's showing us faulty. As I said, it was switching, but it's I think just on its way out, and I just don't think it had enough drive to drive any devices upstream of it. So what we'll do now is look at the analyzer screen and see if the data buses are being correctly updated when the Z80 tries to put data onto the peripheral bus. So looking back at the analyzer, I have this set up in exactly the same way as I did on the previous video. If you haven't seen that video, then what we have here are data A is the input to the buffer, data B is the output of the buffer, there's 8 bits on each side, and then where it's labelled here RAM chip select, I actually have that connected to the chip select line on the UART. I can't use the chip select line on the buffer itself, even though it has one, because that buffer feeds data to all the peripheral devices, and it's only the UART I'm interested in at this point, and I don't want to trigger the analyzer on anything else. So I'll power up the Wren on the analyzer and I'll press reset on the Wren to start the test. So you can see that we've triggered and it looks successful so far. We're now getting 02 on the input and 02 on the output. If you recall from the previous video, we got 02 on the input and 82 on the output because bit 7 was stuck high. If we now scroll across, 87 and 87, that was the same anyway. It always would be because bit 7 was stuck high. Same with the next number, that was a bit indeterminate, except that here we can now see we're getting C, C and CC, which is obviously what we needed in the first place. Going on to the next one, we're getting 46 and 46, and then on to the next one we're getting 0 and 0, and again, if you recall, this was 0 and 80, which was obviously wrong. Now this is another way that the listing comes in handy, because you can actually see, looking at the listing, what values should be fed onto the bus at that point. So we know what the address is that the processor is currently executing, and we can look that up in the listing, see what the data value is the processor should be trying to put onto the bus, and see if that's correct. and I've checked the first 6 and they were correct. We were seeing the correct ones. The Z80 was trying to place on the bus, and the error was definitely on the output of the buffer. So that's another reason for having a listing if you can get it out of the ROMs for the machine. It's like a double pronged attack on trying to fault find. And it also makes it clearer to understand what you're looking at on the screen of the analyzer. If you know what you're actually looking for and what you're looking at, then the testing is much more realistic, and it's much easier to work your way through the faults. So this is looking good so far. We've now got the correct data appearing on the peripheral bus. So we'll look back at the board and see if it's progressing any further. Okay, so we're looking back at the board. I'll turn the analyzer off so that you can hopefully hear me better. And what I'll do now is I'll power up the Wren and we'll watch the error indicator. If you recall, it was flashing 6 times previously to indicate that there was an error with the loopback testing of the UART. So I'll power the Wren up. Okay, I'll reset it. So the caps lock light comes on while it's running the self-test, and now it's flashing an error code, and before we were getting 6 flashes. So if we count them this time, we're getting 9. Now 9 flashes, according to the documents I have, is a real-time clock and RAM test fail. And it's not surprising it's failing because I've got the device here, so that would explain the failure. But the important point here is it's getting past that testing. Not only that, but it's completing tests 7 and 8 as well, and they are also peripheral device tests. So whereas before it was failing on the first peripheral device it came to and identified that as a UART failure, it was really a peripheral bus fault where every single peripheral device would have failed if the testing had carried on. So the other thing I'll do is just quickly we'll look at the data quality that we're getting on the bus now and see if it's any different. So we'll do a capture of the data that's appearing on the bus, and you can see that as well is much better. Before we were getting very high low levels, so it wasn't pulling the bus down as it should have done, and also the edges are much sharper as well. So it does indeed look like this device was marginal and would have completely failed before too much longer anyway. Obviously there's stunting on the screen, which is not surprising because all the other peripheral devices are removed. Now it is possible, of course, that one of the peripheral devices I currently have removed are responsible for killing the buffer chip. So what I'll do now is refit them one by one, and if the buffer chip does fail, it's not too bad because it's now soldered in, or you can't. It's in a socket rather. So although you can't see it, I've put a socket in there, so it'll be much easier to change in future. So the first thing I'm going to do is change the floppy drive controller again so that bit 7 is reconnected. You probably can't see it on the camera, but to make sure this pin wasn't loading the data bus, I bent the pin out of the way of the socket so it's not actually plugged in, but I had to do that because the machine won't run at all without this device plugged in. So I'll just bend that pin back, get the device plugged back in, and we'll see if the machine will still boot. Okay, I have the floppy drive controller plugged in properly, so all the pins are connected. We'll try and boot the Wren back up and see if it still gets to the 9th test. So that's looking good. I'll now refit the real-time clock chip and see if it progresses beyond that test. Okay, so I'll try it again. Of course we still won't get anything on the screen because I don't have the CRT controller plugged in. I also don't have the keyboard controller plugged in. So we'll give this a go. And now we're getting a solid light on the keyboard, which indicates all the self-tests passed. So I'll now plug the keyboard controller back in and see if that test still completes. Okay, I have the keyboard controller plugged back in, so I'll power the machine back up. And again, solid light, so that test is passing as well. Okay, well, as the testing seemed to be going quite well, I've refitted all the peripheral devices. I've refitted the keyboard controller, obviously refitted the real-time clock and SRAM. The UART is of course fitted. I've refitted the A to D converter, the sound chip, and last but not least the CRT controller chip. So they're all now fitted. I'll reboot it and see if it passes the self-test. So what we're looking for is a solid light once the caps lock has gone out, and we're getting a solid light still, so all the peripheral devices, if they're not working, at least they are not preventing the self-test from completing. So display's looking quite interesting. In the next video I'll let you see it. Just kidding. If we move across, we can see that the machine is now actually looking like it's going to boot. Unfortunately I can't get a floppy drive into the drives where they're sitting, so what I'll do in the next video is reinstall the drives into the chassis, and then we'll see if we can actually get the machine to boot from a floppy disk. For anyone interested, the CRT controller chip on this is a 46505. They're quite hard to get hold of, and they're slightly fragile as well. They do seem to be quite easily damaged. I'm quite surprising it's working to this extent. And the fact we're getting lines on the display is quite promising. I'm not sure if this is normal. I've never seen a Wren boot up. I'll try and find some images, but line drawing and the like is normally done from the CRT controller chip, so there could be something going on here we need to have a look at. It could be the chip is failing. We'll try another one in. These types of chips, the 465s, are very hard to get hold of and quite expensive, so if you are repairing one of these or a machine with that type of chip in, they are a pin for pin identical compatible device with the MC68A45, and these are much cheaper, much easier to get hold of. They're used in things like the pets and that type of machine, but they are much easier to find, a lot cheaper than the 465s, and they will work just as well, if not better. These seem to be somewhat more robust. If you want me to look in more detail at the way these chips work and the way the interfaces to them work, then let me know. But as you can see, we've made a big step forward here. It was just the buffer chip that had failed, or was partly failed, and goes to prove what I was saying in previous videos, that quite often chips don't just fail, they start to lose performance, and at some point the system will stop working. That's it for this video. Any comments welcome, but hopefully in the next video we'll get the machine booted from a floppy disk.